This video is for lesson 3.6, adding and subtracting with unlike fractions. In this video, we will be reviewing how to add and subtract fractions with unlike denominators. We will also be including negatives with those fractions. So first, let's just take a look at what it looks like when we add fractions. So we have this rectangle and we split it into thirds. This blue section represents 1/3 of the full rectangle. And we are also going to add half. So if I split it in half, this second blue rectangle represents half of the full rectangle. I want to know by adding them what total fraction of the larger rectangle is filled up. And obviously you can see with the two different sizes, the 1/3 and the 1/2, we can't just combine it and say that there is two sections filled. We need to know exactly how much of the larger rectangle is filled. So to do that, we have to split this up into equal pieces so that we can accurately combine the two blue sections. So the two blue sections since they're not the same size, we can't just combine them and say 2. So what we're going to do is we're going to split it into, this ends up being 6 equal sections. You can see my original 1/3 is now 2 of the 6, and my original 1/2 is now 3 of the 6 sections, and altogether that represents 1, 2, 3, 4, 5 of the 6 sections that are filled with the blue. So you can see it's really important when we add and subtract fractions that both portions are split up into pieces that are the same size, otherwise we can't accurately combine them. So let's take a look at how we add and subtract fractions. So step 1 is the same as step 1 in the last two videos. Convert mixed numbers to improper fractions. Step 2, find a common denominator, and this is something that we only do with adding and subtracting, and I will review how to do that with you in our examples. Once you have that common denominator, step 3 is that you add or subtract the numerators only. The denominator, once you find the common denominator, will stay the same. Just like in our example with the rectangle, we had 2 out of 6 pieces shaded, 3 out of 6 pieces shaded. Our final total is still out of the 6 pieces. So the denominator stays the same, and then finally, of course, we simplify and put it in simplest form if possible. So before we start with any negative numbers, we're going to just review how to simply add and subtract some fractions. So these are not in your notes, so I'm going to walk you through how to do these if you, in case you forget how to add and subtract fractions. So step 1 was to convert any mixed numbers to improper fractions. So 1 times 8 is 8, plus 3 is 11, so we have 11/8, and then plus 1/4. Step 2 is to find a common denominator. A common denominator is a number that is a common multiple of the two denominators. We need these two numbers on the bottom to be the same. So a common multiple of 8 and 4, if you aren't sure, multiples of 8 are 8, 16, 24, 32, 40, etc. Multiples of 4 are 4, 8, 12, 16, 20, etc. The smallest multiple that they have in common is 8. So what that means is I'm going to rewrite my two fractions, and this time they're both going to have a denominator of 8. So the first one already has a denominator of 8, so I can leave that as 11/8. But my second fraction, 1/4, in order to make this into a fraction that has a denominator of 8, I need to figure out what would I multiply 4 by to make it 8. So in this case, 4 times 2 is 8. And I also need to multiply the numerator, 1 times 2, to keep the fraction equivalent. So 1/4 becomes 2/8, and now that I have a common denominator, all I have to do is add 11 plus 2, which is 13, and my final answer is 13/8. There are no common factors that can be divided by both 13 and 8, so I can leave it like that, or I can change it into a mixed number, which would be 1 5/8. Okay, for the second example, you are going to do the same thing, but step 1 is to change mixed numbers, and we don't have any, so we get to skip that one. Step 2 is to find a common denominator. A common multiple of 6 and 9, again, you can list out the multiples, 6, 12, 18, 24, etc. 9, 18, 27, 36, etc. So you can see that the least common multiple between 9 and 6 is 18. So we're going to rewrite my two fractions with the denominators of 18. So we now need to figure out what would I multiply 6 by to make it 18, and what would I multiply 9 by to make it 18. So 6 times 3 is 18. So that means I also need to multiply my numerator 5 times 3 to keep my fraction equivalent. So 5 6 becomes 15/8. And then 9 times 2 is 18, so I multiply the numerator 4 times 2, which is 8. So 4/9 becomes 8/18. Now I have 15/18 minus 8/18, and to subtract, you keep the denominator the same and just subtract 15 minus 8, which is 7. And again, there are no common multiples between 7 and 18 to simplify, so that's our final answer. Okay, so that is how you add and subtract fractions, as long as they are all positives. What I'm going to review now is what to do if there are negatives involved. So this becomes a little bit more complicated, although the general steps are still the same. So remember, in the last chapter, we talked about adding and subtracting with integers, positive and negative numbers. We talked about rules like same signs add and keep the sign, and different signs subtract and take the sign of the bigger number. These rules apply to fractions as well. So let's just review in case we forget these rules, so I can show a few examples here. So let's say we have -4 plus -5. Those are same signs, so we will add them. 4 plus 5 is 9, and then keep the sign, -9. For different signs, subtract, that would be if we had something like -4 plus 5, where you can see 4 is negative, 5 is positive. So we actually subtract 5 minus 4, which is 1, and then we keep the sign of the bigger number, which is 5, so it's positive. If I reverse the signs, 4 plus a -5, same idea, 5 minus 4 is 1, but this time, since the bigger number is negative, so is my answer. One thing to remember is if it's a subtraction problem, we said to change subtraction to addition. So, for example, if the problem was -4 minus 5, we said we would change that to keep the first, change subtraction to addition, and flip the last number to its opposite. So -4 minus 5 becomes -4 plus -5, which you can see follows this first rule up here. Or you might see something like -4 minus a -5, which becomes -4 plus 5. That follows our second example. And then maybe we would have -4 minus 5, which is the same as, 4 minus 5, which is the same as 4 plus -5, which follows our third example. And remember, we said that if we can use the keep, change, flip idea to help us remember how to change subtraction to addition, just make sure you're not getting the keep, change, flip confused between dividing with fractions. Okay, so now we're going to put these two things together. The rules for adding and subtracting and integers and the rules for adding and subtracting fractions. So take a look at your notes. In the coral colored packet, you should see under the adding and subtracting column, you should see this first example written there. So here we have a negative 3/4 plus 2 6/8. We are going to start just like we did with the first few examples by converting the mixed number to an improper fraction. So don't be scared off by the fraction or the negative signs. We're going to handle the fractions just like we did when they were all positive, and then we'll deal with the negatives at the very end. So 2 times 8 is 16, plus 6 is 22/8. So that's step 1, find mixed numbers to improper fractions. Step 2 is find the common denominator. We have 4 and 8, which we actually used these same two denominators earlier, so we're going to use the same common denominator, which is 8. That means we can keep this second fraction the same, and since 4 times 2 is 8, then we're going to multiply 3 times 2 and make it 6. Now be careful, don't forget to carry the negative down. But here's where you're going to use those integer rules. So we know already that my answer is going to have a denominator of 8. All you have to do is solve this problem. So if you look at the two numerators, we have a negative 6 plus 22. That's what we're solving. When we look at it as a fraction, it looks a little intimidating, but here you can just see the two integers, negative 6 plus 22. They're different signs, so we subtract 22 minus 6, and we get 16. And since 22 is positive and it's bigger, then our numerator is positive, 16. We can actually simplify both 16 and 8 by dividing them both by 8, which is 2 over 1, or just 2 as our final answer. Okay, before we do the second example, I'm going to have you try these two, where the signs in the problem are already addition. So take a few minutes to try these two examples, and then I will explain them to you. Okay, so step 1 here is to get rid of this mixed number. Then step 2 is to make a common denominator. So our numbers are 3 and 2. A common multiple of 3 and 2 is 6. So I'm going to make both of these denominators 6. To do that, we need to multiply 3 times 2. So I will also multiply the numerator 1 times 2. And for our second fraction, I need to multiply 2 times 3 to get 6. So 3 times 3 makes our numerator 9. Our final denominator before we simplify is 6. And then remember I said that all you need to do is look at the two numerators. Here we have negative 2 plus negative 9. That's the problem that you're solving. And we get a negative 11. Same signs, add and keep. 6 and 11 have no common factors, so you can leave it like that, negative 11/6, or you can write it as negative 1 5/6. For the second example, we have no mixed numbers, so we're just going to rewrite the problem with a common denominator. Common denominator between 6 and 12 is 12. So that means our second fraction can stay the same, and I just need to multiply the first one by 2. So we have 10/12 plus negative 1/12. We know the 12 will be our denominator, and we are just looking at the numerators now. We have 10 plus negative 1 is what we're trying to solve. These are different signs, so we subtract. 10 minus 1 is 9. And that's positive. And then we can simplify 9 and 12 both by dividing them both by 3. So our final simplified answer is 3/4. Okay, one more example on your notes. This is a subtraction problem. You see there's a subtraction sign in the middle. So what I'm going to have you do before anything else is rewrite this problem as an addition problem. So we keep the first, change subtraction to addition, and flip the second to its opposite. So -2/5, the opposite is +2/5. So we are no longer looking at this subtraction problem. Now we're looking at an addition problem, which is nice because it uses the same rules that we already know. Same signs, add and keep, different signs, subtract. So now we can move on in our steps for adding fractions. So we are going to look for a common denominator. That is going to be between 10 and 5. We can use 10. So that first fraction can stay the same, and then multiply the second fraction times 2 to get a denominator of 10. So 2/5 becomes 4/10. And then at the very last step, we just need to solve -1 plus 4, which is 3. And that is our final answer. Again, make sure you wrote that on your notes in the coral colored packet. And I have 2 more examples for you to try on your own. Okay, here they are. Here are the 2 answers, and I'm going to show you how to get those. So we have 2/9 minus 1/2. So I'm going to start by changing that to 2/9 plus a -1/2 so that it's an addition problem, and we can use the addition rules. We need a common denominator, which in this case, a common multiple of 9 and 2, we will just use 18, which is 9 times 2. So to get 2/9, we will multiply by 2, which becomes 4/18. And we will multiply the second fraction times 9. 1/2 becomes 9/18. Our final answer, we know we'll have a denominator of 18, and we are working on this problem 4 plus -9. Those are different signs, so we subtract 9 minus 4, which is 5. And since 9 is bigger and it's negative, our answer is negative. All right, for the last question, I'm going to change this problem so that it is -3/4 plus a -1 2/3. Keep, change, flip. Then I need to rewrite that mixed number as 1 times 3 is 3, plus 2 is 5, so -5/3. We need a common denominator, a multiple of 4 and 3. We will use 12. So we are going to probably run out of space, but we'll do our best. So to get 4 to turn into a denominator of 12, we need to multiply by 3. So then we also need to multiply our numerator by 3. And then for our second fraction, we will multiply these by 4. And again, we know our final answer will have a denominator of 12. The denominator stays the same, and we are looking at -9 plus -20. Those are the same signs, so we add and we keep the sign. So our final answer there is a -29/12. Or you could turn that into a mixed number, but again, you do not need to. That was a lot of information, so the last thing I want to talk about are just some key words to help us identify whether a word problem would be addition or subtraction. So this first example says, while making desserts for a bake sale, Luke used 1/2 of a scoop of brown sugar as well as 1/10 of a scoop of white sugar. How much more brown sugar did Luke use? The key words here is how much more, and that would represent that we would need to subtract the two amounts to figure out how much more one was than the other. In the second example, 3/10 of the students in the band are in the trumpet section, 1/10 of the students in the band are in the trombone section. What fraction of students in the band are in the trumpet section and trombone section combined? That's our key word, and this would be addition. And lastly, Mrs. Palmer is making banana bread for her family. After she began mixing ingredients, she realized she didn't have any flour. So she borrowed some from her neighbor. She used 3½ cups in the recipe and had 1 3/4 cups extra left over. How much flour did she borrow? This one is a little bit trickier than the first two. We know that she used 3½ cups, and then she had 1 3/4 cups left over. So to figure out how much she borrowed all together, it doesn't say that, but we want to know how much did she borrow in total. We actually need to add how much she used in the recipe plus how much she had left over. So this would be addition. Okay, so for your adding and subtracting fractions, please take your time, be careful, go back and re-watch parts of this video. If you need some extra help, please let me know.